cold. I wish there was a headband I could get that would take my brainwaves and give me the right sleep state so I could just regulate the temperature with this blanket.
Bad boys, what you gonna do when you come for me?
And just like that, the bad boys of Team 8's mission had begun. I personally contributed to the research, implementation, and testing of the EEG device. We started with a road bumper not having our PCBs delivered on time, so we had to recreate our circuit on a breadboard and redesign it to account for the breadboard's stray capacitance. To remain sustainable, we used all of our through-hole components from our previous courses. We began testing our EEG at different electrode positions. After several days of testing, we struggled to see the brainwaves due to the test subject's alertness and incorrect gain, which meant we had to redesign our circuit in order to increase the gain.
Merna and I worked together to create a blanket consisting of recyclable electronic components, promoting a cradle-to-cradle process. To achieve an optimal layout, a grid structure of Peltier modules and temperature sensors were created, where heating and cooling tiles alternate to provide maximum comfort. Temperature sensors for the torso were placed away from Peltier modules to accurately measure the user's temperature. Combined with data received from the EEG headband, an ideal temperature was found. After carefully calculating the minimal number of temperature sensors and Peltier modules needed, the total cost of the blanket proof of concept came out to be $388.97.
Since our EEG circuit was designed to filter out 50 to 60 power line frequency, it made it even harder to see our waves since our awake stage was also in that frequency range. To combat our small gain, we added a new amp that would mimic the powerful amp we originally planned to use for our PCB to amplify our signal. And we changed our resistor ratios to increase the gain so we'd be able to see the signal on the oscilloscope and begin testing our EEG with our microcontroller.
Due to COVID-19, lab access was abruptly restricted, preventing use of a power supply for the proof of concept. Thus, red and blue LEDs are currently implemented to demonstrate the heating and cooling functionalities respectively. Upon initialization, the blanket waits for the user to be detected before grasping the base body temperature. This temperature is compared against current temperatures throughout the remainder of their sleep cycle to determine the perfect temperature range for the user. During the sleep cycle, the body temperature of the user will also fluctuate, but the human body is most sensitive to temperature changes in REM, which is where the blanket excels with stabilizing external factors to promote sleep. Once the ideal temperature is determined and compared to the current body temperature, the blanket will then decide if it must heat or cool. This switch is performed via a relay, since the heating and cooling functionality is separated on their own power rail. Keeping the user's safety and the weight of the blanket in mind, the separation of temperature regulation also allows heat sinks to be mounted only on the heating side of the Peltier modules.
I contributed towards the design and implementation of our EEG device, which detects the differential input from two electrodes and as a third electrode that acts as a reference electrode. The device is currently in a box covered by aluminum foil for shielding. It will be transferred to a PCB and attached to a headband with the Arduino and electrodes once we're able to borrow a soldering station. The detected brainwave signals from the EEG circuit are filtered, amplified, and the output is passed into the Arduino, where our frequency calculation algorithm is used to determine the user's sleep state based on the detected signal frequencies. All components can be recycled or reused by dropping them off in electronic component and material recycling bins. We've spent $219.42 Canadian on the EEG proof of concept.
I contributed to the signal processing in the EEG and the synchronization between EEG and the blanket. The EEG sends the blanket integer number where 1, 2, and 3 means awake, non-REM, and REM, and number 4 requests for the body temperature. When the EEG is turned on, it requests the body temperature by sending 4 to the blanket. The blanket receives it and replies the temperature in degrees Celsius. EEG stores the value as awake body temperature. It calculates the frequency, requests the temperature again. The user is now determined to be awake, so the code of 1 is sent to the blanket.
Now that I have this easy blanket by EazZZy, I am ready to hit the Z's, man.
Yeah.